Hello students, today we will discuss the ion exchanger process. So in addition of the zeolite process, ion exchange method is one of the most important water softening process. So basically in ion exchange process, in this remove the hardness present in the water by using resins. So resins are the polymer with microporous structure, and as we discussed in the previous lecture, in ion exchange process there are two different kinds of the resins are applied, called cation exchanger resins and anion exchange resins. So cation exchange resins are capable to exchange their H plus ion with their cation in the water, while anion exchange resin are capable to exchange their OH minus ion with anion in the water. So the hardness present in the water in the form of calcium chloride, calcium sulfate, calcium bicarbonate. So in there the calcium is contain the positive charge and chloride is contain the negative charge. So those substances having the positive charge, they can be exchanged by the cation exchanger resins, and those contain the negative charge like Cl minus 2 here, and sulfate and carbonate, they also can be exchanged by the anion exchanger resins. So basically this chemical reaction is occurred in the process. So the hard water is passed first through the cation exchanger column, which remove all the cations like calcium and magnesium from it. Okay, an equal amount of H plus ion only is released. So here the these calcium and these magnesium salts, they can be trapped by the cation exchanger resins, and only H plus ion are released from the column to the water. Okay, so this chemical reaction is occurred into the cation exchanger column. This reaction is occurred in cation exchanger column. So these chemical reactions occurred into the anion exchanger column. So in anion exchanger column, when the hard water is passed through the anion exchanger bed, so which remove all the anions like sulfate and chloride, bicarbonate, carbonate. Okay, so these can an equivalent amount of OH minus are released from the to the column. So these chloride, sulfate, they can be trapped by the anion exchanger bed, anion exchanger resins like this, and here only OH minus ion are released, and they can be trapped by the anion exchanger resins. So after that, uh, these H plus ion and OH ion, they get combined and produce here the water molecules like H plus ion and OH negative ion released from the cation exchanger and anion exchanger column respectively, means that H plus ion is released from the cation exchanger bed, and these OH negative ion are released from the anion exchanger bed. So they get combined here and produce the water molecule. So these water is known as the deionized water or demineralized water. It is the soft water. So more clearly we can understand the whole process in this diagram. So this is the diagram for the ion exchanger process, where the two cylindrical column is present is here. So first this column is the cation exchanger column, that is the anion exchanger column, where means it is contained the cation exchanger bed, means cation exchanger resins is here. Okay, and it is contained here the anion exchanger resins, and it is also linked by the gravels. Here is the gravel. So gravels are the like stone. So first of all we have to inlet the hard water from this pipe. Okay, and then that hard water is entered through this pipe, and that hard water is can be pass through the cation exchanger bed into the sprinkle form, in spray form. Okay, and this cation exchanger bed can be retained the calcium and magnesium salts present in the water. Okay, and H plus ion or rest of the negative salts like chloride, sulfate and bicarbonate, they can be passed through by these pump and can be entered again into the anion exchanger resins, where all the chlorides and sulfates, these types of the minerals can be trapped through the anion exchanger bed, and here this OH negative ion and H plus ion released from the cation exchanger column, they get combined to here and produce here the soft water. So basically these chemical reaction, these both chemical reactions and this chemical reaction is occurred here in cation exchanger column, in anion exchanger column, and we can get the soft water is here. Since that is the regular process, this is a continuously going on process in industry, so eventually all the resins exchange sites are occupied by the calcium and magnesium, and no further softening exchange can take place. So the resin is said to be exhausted. So these can be exhausted and must be regenerated, which is reactivated by the pass of acidic solution and alkaline solution. So this process is known as the regeneration. So when the efficiency of these beds are deactivated, so they can be again activated through the passing of the acidic solution and alkaline solution. So here the hard water is stopped after that. So that acid regenerator, so acid can be passed through to the bed. Similarly, here the alkaline solution is passed through the anion exchanger bed. So acid pass through on cation exchanger bed, and alkaline is passed through onto the anion exchanger resins. So they can be, this process is known the regeneration. So regeneration, when the capacity of cation and anion exchanger to exchange H plus ion and OH negative ions are lost, they are said to be exhausted. So the exhausted cation exchange column can be reactivated or reclaimed by the passing solution of dilute acid, and exhausted anion exchanger column is reclaimed by the passing a solution of dilute base. So these following chemical reactions occurred here. So exhausted resins reacted with dilute acid produce here the cation exchanger resins, and then exhausted anion exchanger resins is reacted with base alkaline solution is produced anion exchanger resins, and these calcium and chloride, these washing can be drained out from here to the sink like this. Okay, so this is the whole process is known as the regeneration. So this method is having the advantage it produce the very very soft water. They contain the very less hardness, less than to the 10 ppm, and the process can be used to the highly soft by highly acidic and alkaline water. So that is process is produce the highly soft water compared to the zeolite method. Anyhow, it is also having some disadvantage, means there the different kinds of the costly chemicals are utilized for this in this process, like different kinds of the resins and regenerator chemicals like acidic and alkaline solutions. So overall cost is high compared to the zeolite process. So that is the disadvantage of this process. But anyhow, this is the one of the most important method generally applied into the industries, where we can get the soft water, and that soft water can be further applied in different kinds of the boiler and different kinds of the industrial purpose. Okay, so I hope you have understand all these things. If you have still any doubt, so you can send to me the mail. Thank you very much.